ever just stop and think about the magic that's happening all around you? I mean, your computer, your phone, your smart TV, even your printer. They're all talking to each other all the time. But how? Well, it's not magic. It's actually a really clever system we use every single day. It's a network. And we're about to pull back the curtain on the whole thing.
So let's just ask it straight up. You hit print on your laptop, and boom, seconds later, the printer across the room starts making noise. How did that command get from point A to point B? What is this invisible web that's holding all our tech together?
And the answer, my friends, is the local area network, or what we all call a LAN. Honestly, the best way to think about it is like a private digital neighborhood just for your devices. It's this little self-contained world where all your stuff is connected, sharing info like they're all living under one roof. It's your own personal digital space.
So here's how we're going to tackle this. We're going to build our understanding of LANs from the ground up. We'll start with the basic building blocks, then see how networks are designed, jump into the classic wired versus wireless debate, and finally, we'll zoom out and see how your little local network connects you to, well, the entire world. All right, so what's actually in a network? What are the ingredients? Whether it's your small home setup or a massive corporate office, it really just boils down to three main things. Let's break them down. First up, you've got your end devices. These are the stars of the show, right? They're the things you actually touch and use every day. Your computer, your phone, a server humming away in a closet. These are the devices that are actually creating and consuming all the data that's flying around. But of course, those end devices can't just talk to each other out of thin air. They need a little help from the network devices. Think of these as the traffic cops of your network. A switch is like a local dispatcher, connecting all the devices within your LAN. A router, that's the gateway, connecting your entire LAN to other networks, like the big one, the internet. And a firewall, well, that's your bouncer, checking IDs at the door and keeping the network safe. And last but not least, how does all this data get from one place to another? It travels through the network media. This is the actual road the data drives on. It could be a physical Ethernet cable you plug into the wall, or it could be the invisible radio waves that make up your Wi-Fi. They're just different kinds of highways for your information. Okay, we've got the parts, but how do we put them all together? See, a network isn't just a chaotic mess of wires and signals. No, it's a very carefully designed system that tells all that information exactly where it needs to go. Now, this is a super interesting concept. On one hand, you have the physical topology. That's the actual, literal layout of the wires. If you could see through your walls, that's what you'd see. But then you have the logical topology, which is the path the data thinks it's taking. A great analogy is a subway map. The physical tracks might twist and turn all over the city, but on the map, the logical path, it's just a straight line from one stop to the next. Now, in the old days, we had a few different physical layouts. A bus was kind of like one main street with all the houses connected to it. A ring was like a circular train track where data went from one station to the next. But today, pretty much everything is a star topology. That's where every single device connects to one central point, usually a switch. And why did the star win? Simple. It's so much more reliable. If one cable breaks, only one computer goes down, not the whole network. It makes fixing things a million times easier. So the paths are all set up, but when one device sends out a message, who's it for? Is it a private note passed between two people, a memo to a specific team, or a big announcement for everyone to hear? Let's check it out. First, you've got unicast. This is simple. It's one-to-one communication. It's the network equivalent of sending a direct message to a friend. The little packet of data has a very specific address on it, and the network makes sure it gets delivered only to that one recipient. And this visualizes it perfectly. Check it out. The computer on the left sends a packet. The switch in the middle is smart. It looks at the address and sends it only to the intended computer. It doesn't bother any of the other devices. Super efficient, super private. Then we have the total opposite, broadcast. This is a one-to-all message. Think of it like someone grabbing a megaphone and making an announcement in a crowded room. Everybody on the local network gets the message, whether they needed it or not. And you can see exactly what happens here. The source sends out one packet with a special broadcast address. The switch sees that and says, okay, this is for everyone, and it copies that packet and blasts it out of every single port. It's super useful for things like when a new device joins the network and needs to shout, hey, is anyone out there? I need an IP address. And finally, there's multicast, which is this awesome middle ground. This is a one-to-many communication. It's basically a group chat.
The sender sends out just one packet, and the network is smart enough to deliver it only to the devices that have said, hey, I'm interested in this conversation.
This diagram shows it beautifully. The source sends a packet meant for a specific multicast group. The network knows exactly which devices, in this case the 2 laptops on the right, are part of that group, and it sends the packet only to them. This is way more efficient than a broadcast, especially for things like streaming live video to a bunch of people at once.
Okay, let's switch gears and talk about how we physically get connected. And that brings us to the classic showdown, the trusty old-school wired network versus the convenient modern wireless one. When you look at these diagrams, you see that wired and wireless networks are trying to do the exact same thing, connect devices to a central point. The big difference isn't really the layout or the design, it's the medium. One uses physical cables, the other uses invisible radio waves. So, which one's better? Well, it's a classic trade-off. As you can see here, a wired Ethernet connection is still the king when it comes to raw speed and rock-solid reliability. But you're tied down by a cable. Wi-Fi gives you that amazing freedom to roam, but that comes with a price. Your signal can get messed with by other devices. It's really the difference between having your own private, dedicated highway for your data, that's Ethernet, versus sharing a busy public airspace with everyone else, that's Wi-Fi. Okay, so we've built our own private little network. We know how it works. But we all know the story doesn't end there, right? Your LAN is your personal launchpad to a much, much, much bigger universe. Your LAN connects through your router out to the internet, which, when you think about it, is just a giant collection of other networks all talking to each other. This image is a great example. It shows how someone's home LAN can create a secure, encrypted tunnel all the way through the public internet to connect to their office's LAN. That's the whole idea behind a VPN, a virtual private network. It's about extending your private, safe space across the wild west of the public internet. And really, that just brings it all home, doesn't it? Every time you go online, you're connecting your little local area network to this massive, global web of millions of others. What is the internet, if not just a network of networks? And it all begins with that one humble LAN humming away quietly in your own home.